So the first thing we need before we start studying molecules is we need a definition for what molecules are. Obviously, if we can't define what it is, we're not going to know when we see one, and we're not going to know when we don't see one. The first thing we need to note is, of course, that molecules can be defined in many ways. Different people have defined molecules differently, depending on the application of their science. But typically, a molecule is any electrically neutral compound consisting of two or more atoms bonded together with covalent bonds. So here's just a lot of words, and the key ones to look at are it's electrically neutral, so it's not charged, and there's covalent bonds inside them, and that's what we call a molecule. Two or more atoms. Those are the kind of things that we're looking for. That excludes a lot of things that act like molecules. We use a more general description of what a molecule is. So a molecule is the smallest particle of a substance that contains the chemical and physical properties of that substance. It sort of sounds like what an atom is, right? An atom is the smallest substance that can't be subdivided. But this includes all substances. So this includes any substance, the smallest particle of any substance that still retains all of the chemical and physical properties of that substance. The reason why we use this generalized definition is because it allows noble gas atoms, which act a lot like other molecules, to be considered as molecules as well. So even though the noble gases are not bonded to anything, we can still call them molecules so that we can use the same sort of mathematics on them as we could on other molecules. So that's why we use this generalized definition. And this generalized definition has other applications other than chemistry. We also use this type of definition in thermodynamics and other studies of chemicals, maybe not with the same focus as chemistry though. Noble gases and other molecules. So most molecules that we come across are diatomic or polyatomic structures. So diatomic, di meaning two, atomic meaning atom. Diatomic is two atoms. So diatomic molecules, what can we think of like that? H2, that's two atoms in there. O2, F2, Cl2. These are all diatomic molecules because there's two of them. Two atoms in each molecule. Or we could have polyatomic molecules, which obviously have more than two atoms. So one typical one would be CO2. Polyatomic because there's three. You could call it triatomic if you really wanted to, but we'll just say polyatomic for now. So you can see there's one carbon atom and two oxygen atoms. So fairly simple. So obviously these polyatomic and diatomic molecules include O2, N2, and CO2. Molecules can exist as single atoms, as I mentioned before. And in the case of noble gases, these substances are composed of single atom molecules. So noble gases such as helium, neon, krypton, argon, all of those exist as single atoms, but as a gas. So molecule movement and interaction. So molecules are particles that follow the constraints of kinetic theory of gases. Okay, so that could be probably the best definition of what a molecule is. They're anything that follows the kinetic theory of gas. But that could exclude some other chemicals as well, which may be molecules, but may not act in the kinetic theory of gases. In the kinetic theory, as we've talked about ad nauseam in other videos, these particles move independently of one another and only alter their path when they collide with other particles or obviously container walls and things. So all of these particles in this little flask are moving in their own sort of way, own direction, randomly at random speeds, and they only change their direction if they collide with something. That's what molecules do. That's how molecules behave. They behave randomly, and so they only interact when they collide with one another. Okay?